Let's take a look at the anatomy of a confidence interval. I have an example here from StatKey. The original data was 157 restaurant tips, and the average tip was 3.849. And here are all the individual 157 tips. I then asked StatKey to resample from the original 1,000 times and then plot the averages of each of the 7,000 samples. This is what's called a sampling distribution. In this case, is a distribution of sample means, and we need something like this in order to make a confidence interval, whether we do it with theoretical formulas or some kind of simulation software like this. So what I want to do is explain what each of these numbers here in StatKey's simulated sampling distribution represent in terms of a confidence interval. So we have a confidence level, that's important. Confidence level basically says how much of the sampling distribution do we want to put in the center. Standard is to go for 95%. Again, that's abbreviated CL, confidence level. Then a little bit goes in the tail. If you take the confidence level away from 1, that gives you a value we call alpha. And then the tails have to split alpha. So then alpha over 2 is what goes into each tail. So if I take 1 minus 95%, that's going to give me 5%. And then if I take 5% and cut it in half, then I'm going to get 2.5%, which I could state as a decimal or a percentage. I'm going to write it as a percentage here. So 2.5% in that tail, that's alpha over 2. Same thing over here in this tail, 2.5%. Again, that's alpha over 2. In the center on the number line here, I mark the mean of the distribution. Now, the mean of the distribution should be approximately the mean of the population, and we're approximating that with the sample mean. My sample mean was approximately 3.848. So what we can say is, based on the sample we have here, we think the average tip at this restaurant is around $3.85. Now, since we don't have all tips, then we have to come up with a margin of error for this estimate or an interval. So StatKey states the interval instead of the margin of error. We'll find the margin of error in the moment. StatKey said the lower estimate here would be 3.481. And the upper would be 4.231. So now, based on StatKey's estimate of the average tip, I can say the average tip is somewhere between $3.48 over here and $4.23 over there. The margin of error is the distance from the center to the edge. Now, in theory, they should be the same, but when we run a sampling distribution, because of variability in sampling, the distance from the center to the edge is not always going to be symmetric. So to find our margin of error, often I call that the ME. So margin of error. Sometimes abbreviated ME. In this case, since this is a mean, we might call it the error bound on the mean, EBM. And from a bootstrap sampling distribution like this, the best way to find it is to find the difference from the lower to the upper and then cut it in half. And that'll give us the best margin of error here. So in this case, I just want to do a little subtraction. So I'm going to take my 4.231, subtract from it 3.481. And let's see what we get there. And then we'll cut that in half. So that's the distance all the way across. Margin of error is the distance from the center to the edge. Since this is probably not symmetric, we average the distance across. So let's see, subtract, we get a 0 there. 3 take away 8, we get a borrow. So what is that, 5? That's a 1 now, we get a borrow again. Calculator's helpful too. We get a 7 there. And then we want to cut that in half. So 2 goes into 7 3 times with 1 left over. 15, 7 times with 1 left over, and 10, 5 times. So I'm getting the margin of error. The error bound on the mean is about 38 cents, 0.375 based on these two endpoints. So that's my margin of error. When you look at research that tries to estimate some population parameter, like an average, you'll find that the research will state that result in two different ways. They'll either state the interval by saying we think it's somewhere between this number and that number, or they'll say we think it's this number here with this margin of error right there. And the values that I've highlighted there always match the numbers I started with in terms of the units. So if I'm talking about dollars, then all of those numbers are dollar amounts. If I was talking about body temperature, then all of those numbers would be body temperatures and so on. So again, anatomy of a confidence interval. Enjoy.